Hi guys, we're going to continue with changing of subject to the formula, and in this video we're going to solve two y questions. And the first question we're going to solve for today is this: make t the square root of formula a is equal to square root of 1 over m all over 1 over t minus 1 over v. And the second question says that make q the subject of the relation t is equal to square root of pq minus r squared q over r. And let us start with the first question. The first question, we have a is equal to the square root of 1 over m all over 1 over t minus 1 over v. So, if you look at it, this is a fraction. We have to solve the internal, what is inside the square root first, before we resolve, before we remove the word, the square root. What we are looking for is actually what? T. And t is inside the square root, which means we have to find a way to remove the square root later. So, we have a is equal to the square root of 1 over m, and I want to solve this equation. We have 1 over t minus 1 over v, and the LCM of t and v is t. T cancel t divided by t, it will cancel away, then v. V times 1, we have v. We have v, then minus v, we cancel v, we have t times 1, we have t. Remember, there is another over here. What I did is that only this one, we find the LCM of t and v, we have tv. So t divided by t cancel, we have v times 1, we have v, minus v cancel, we have t times 1, we have t. So here is what we have. So, like I've said, so what you're going to do now is that we have to, so inside the bracket, we are going to, we have a is equal to the square root of, this is division. We have 1 over b, 1 over m. This is this division, I can change to normal division sign. V minus t all over tv. So what I did is that I removed this 1 over m, then this long division is divided by v minus t over tv. So we have a is equal to the square root of 1 over m. I will change this division to multiplication and reciprocate this fraction, which will change to tv all over v minus t. So we now have a is equal to the square root of 1 times tv, we have tv, all over m, open bracket v minus t. So remember, we are still looking for t. The first thing you should do is to remove this square root. And how can you remove the square root? By squaring both sides. Squaring both sides. Squaring the both sides. And what we have is a is equal to the square root of tv all over m, open bracket, v minus t. Then you square both sides. I'll square the right hand side, also square the left hand side. Then this square will cancel the square root. Now here we come a square is equals to tv all over m, open bracket, v minus t. And the next thing is, you see there is t at up and also t at down. Now, what you're going to do is that we have to make this as a fraction and cross multiply. Cross multiply. If I do that, I'll now have a 1 times tv, we have tv, is equal to a squared times we have a squared, then m, open bracket, v minus t. And the next thing is to expand the bracket because there is t at the right hand side and also t at the left hand side. Having been that t is one side, we have our final destination. But now, since that the t is at the right hand side, also at the left hand side, we have to expand the bracket. We have tv is equal to a square m, a square m times we have a square mv. Then minus a square m times we have a square mt. And with this, we can see now that t is here and t is here, and this side there is no t, which means we can now collect the like terms. So we now have TV. So this is minus a square mt. Take it to this side, we have plus a square mt is equals to, we have used this, what is remaining is what? A square and v. Now, if you look at this, what is common? T is common for this side. T is common. We have T, open bracket. If I remove T out of this, we have V plus, if I remove T from here, we have A square N is equals to A square and V. So we have to divide both sides by the coefficient of what? T is V plus A square N. Divide both sides by V plus A square N. V plus A square N. This cancels this. We now have the final answer as the final answer for the first question is T is equals to A square M V all over V plus A square N. This is the final answer for the first question. Then we move to the second question. We'll go for break and come back. Now, welcome back. We are going to solve this number 2. I will write the question as this. Sometimes they will not write it in a statement that should make anything so the formula. They write it like this for you. They will just say evaluate. So T is supposed to be. They now put Q in bracket, meaning that we are going to make Q the subject of the formula. Now, what you are going to do is that look at Q is inside bracket, the square root. The first thing you should do is to remove the square root by squaring both sides. Squaring both sides. So if I do that, I'm going to have T, then square is equals to the square root of P Q minus R square Q all over R. Now what I did is that I squared this left hand side, I also squared the right hand side. So the square will cancel the square root. We now have T squared is equals to PQ minus R square Q all over R. Now, we are looking for what? Q. We are going to make Q the solid formula. What you are going to do is that there is Q here, there is Q. You have to remove it out. Which means that we have T square is equal to Q, open bracket. If I remove Q out of this place, we're going to have P minus, if I remove Q from here, remember what? R square all over R. So the next thing is to make this over 1 and cross multiply. Cross multiply. If I do that, I will have R T square times R, we have T square R is equals to 1 times all the variables here, we still have the same thing as Q, open bracket P minus R square. So it's very easy for us to find Q now because Q is not attached to anything again. So we have to divide both sides by the coefficient of Q, which is divided by P minus R cubed, P minus R squared. Then this cancels this. We have Q is equal to T square R all over P minus R squared. This is the final answer to this question. Please do well to subscribe to this channel. Thank you and peace out.